second part of this section is going to deal with the square of a binomial. In order to be able to complete this section, you need to understand the distributive property. You need to be able to understand how to multiply binomials using FOIL. You need to be able to apply the rule of exponents, including the product rule. And you need to understand how to multiply, add, and subtract monomials. In this section, we're going to look at the square of a binomial. And if you want, you can memorize the formulas, but again, I don't believe in memorizing formulas unless it's required. And so basically what we're going to be doing is multiplying a binomial by itself. We have the formulas here, and as we proceed through the examples, we'll see that this is in fact what we are going to end up with on each one of them. A couple things to note in this section, though, is that you are not allowed to distribute the exponent. You don't just square A and square B and then you're done. Because basically, what do we do when we multiply two binomials? We have to FOIL. We have to do first, outsides, inner, and last. Same thing is true when we square it. We are multiplying a binomial by itself, i.e. another binomial. And so we will have to FOIL. I will say that this is the most commonly missed problem in the chapter. Remember that you are not required to memorize these formulas as long as you remember how to multiply binomials together. So let's go ahead and look at some examples. Now, the first thing is whenever you see these problems, you should go ahead and rewrite this in expanded form to make it easier on yourself. So for instance, when we look at x plus 3 squared, the first thing that I want to do is I want to rewrite this as an expanded form, or x plus 3 times x plus 3. From here we can go ahead and FOIL, and if we FOIL, we should get our first is x squared, x times x. Our outsides, x times 3 is 3x. Our insides, 3 times x is also 3x, and our lasts, 3 times 3 is 9. From here, if we go ahead and combine our like terms, we do in fact get x squared plus 6x plus 9, and we're done. Let's look at a couple other examples. So let's go over to example B. We have 3x plus 7 squared. So again, the first thing that I want to do is write this in expanded form. So I'm going to have my 3x plus 7 times 3x plus 7. From here, if we go ahead and FOIL, my firsts, 3x times 3x, gives me 9x squared. My outsides, I get 3x times 7 is 21x. My insides, 7 times 3x gives me 21x. And my lasts, 7 times 7 gives me 49. If we combine our like terms, we can combine the two middle terms. Everything else we'll go ahead and just bring down. So we have 9x squared plus 42x plus 49. And we're done. Okay, so these are some examples of the binomials where we have a plus sign in the middle. So now we want to look at some binomials where we have a minus sign and see how does it change it. So if we look at example C, again I'm going to write this in expanded form, so I have x minus 10 times x minus 10. Alright, if we multiply our firsts, we get x times x is x squared. Outsides, we get x times negative 10 is minus 10x. Insides, we get minus 10 times x is minus 10x. And our lasts, we get negative 10 times negative 10 is positive 100. When we combine our like terms, we have x squared. Combine the negative 10x and the negative 10x to give us minus 20x plus 100. So one thing to note here is that our last term will be positive always. Our middle term will always be the same sign as whatever we have here. Let's look at one more example like this. Let's come over to example D, where we have 5x minus 4 squared. I'm going to start by writing out in expanded form. So we have 5x minus 4 times 5x minus 4. And now if we FOIL, we get 5x times 5x is 25x squared. 5x times negative 4 is minus 20x. Insides, we get minus 4 times 5x is minus 20x, and my lasts, negative 4 times negative 4 gives me plus 16. Combining our like terms, we get 25x squared minus 40x plus 16. And we're done. Now, we can extend this to polynomials that have more than one variable. And so if we look at example E, 5x plus 3y squared, we're going to do basically the same thing. So we start off by writing in expanded form. We get 5x plus 3y times 5x plus 3y. If we multiply our firsts, we get 5x times 5x is 25x squared. My outsides, we get 5x times 3y is plus 15xy. My insides, I get 3y times 5x is plus 15yx or 15xy. I'm going to write it as xy just so that it's in the same order as my previous term. And then finally my lasts, we get 3y times 3y is 9y squared. From there we can combine the two middle terms and we get 25x squared plus 30xy plus 9y squared for our final answer, and we're done. Again, in this section, just be very careful. Make sure that you remember to write in expanded form or that you have the formula memorized. But again, I don't encourage memorizing formulas just for the sake of memorizing formulas. Real fast, if you do want to use the formula, let's look at an example of that just to show how does it work. So remember, our formula is a plus b squared equals a squared plus 2ab plus b squared. I'm going to do the last example just to kind of show how this works. So if we have 5x plus 3 squared, what does this mean? This means that a equals 5x, b equals 3y. So what we're going to do is square 5x plus 2 times 5x times 3y plus 3y squared. Now we simplify. 5x times 5x, that gives me my 25x squared, plus multiply my numbers in the middle term. We get 2 times 5 is 10 times 3 is 30xy plus 3y squared gives me 9y squared. And note that we do get the same answer. So that's how you would use the formula on these. We will see some formulas later this semester when we talk about factoring, and we will see something different, and we'll kind of be doing the exact opposite of this, but breaking it down into its individual factors.